Hey guys, so this is a review of how to simplify radicals, and there's a couple different methods that you can use when simplifying radicals, and I'll show you both of them. All right, so the first method I'm going to show you is what I've heard referred to as the cake method. So we are going to basically break the numbers down by their prime factorization. So if you can remember back in like third grade when you did the factor trees where you just like broke it down, that's the same thing we're doing, but we're going to do it with a little more structure. Okay, so if I have prime numbers and I just want to list the first few primes. Now remember, primes are a number that's only divisible by 1 in itself. So 1's not considered prime. We're not going to get into that conversation, but 2, 3 is. 4 is not because 2 times 2 is 4. 5 is because the only way you can get 5 is do 1 times 5. 6 is not, 2 times 3. 7 is, 8 is not, 9 is not because 3 times 3. 10 is not, 11 is, no 12, 13 is, not 14, not 15, not 16, 17, 19, we're going to stop there. Okay, so what I want to do is break 512 down by its prime factorization. Okay, and I'm going to do it this way. It looks kind of like an awkward division sign. So for sure, since 512 is even, we know it goes 2 goes into it. So if you do 512 divided by 2, you get 256. Okay, and then we want to do the same thing to 256. Well, we know 2 goes into that because it's even, so when you divide that by 2, you get 128. Okay, well, still even, so still 2, so 64. We can divide 64 by 2 to get 32, 2, 16, 2, 8, 2, 4, 2, 2, 2, 1. When we get to 1, we're done. Okay. So notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. So basically what I'm saying is 2 to the 9th is equal to 512. And if you want to check in your calculator, you can, but I'm pretty confident that is correct. Anyways, so after we do this, we want to group these into pairs. So we have a pair of 2s, a pair of 2s, a pair of 2s, and a pair of 2s. Okay, so every pair can go out front. So I can say pairs go out front, leftovers go inside. Okay, and if there's more than one pair, we will multiply. Okay, so if I'm just breaking down square root of 512, which I should have told you, we're going to worry about the m to the third here in a minute. Okay, this is going to equal, well, 2 times 2 times 2 times 2, because there's 4 pairs, so 2 times 2 times 2 times 2 is on the outside, and then we have a leftover 2 on the inside. So 2 times 2 is 4, times 2 is 8, so 16 square root of 2. So square root of 512 equals 16 square root of 2. Okay, now we're going to do the same thing with this m cubed. So m cubed, and you don't really have to write it all out like this, but it's just you take m out, you get m squared. You take m out, you get m. If you take m out, you get 1, 1, you're done. So you want to pull out the m's. You have a pair of m's and then a leftover m. So the pair of m's come out front, leftover m's go inside. Okay, now we know that square root of 512 m cubed is the same thing as square root of 512 times square root of m cubed. We know the square root of 512 we just found is 16 square root of 2. And we know square root of m cubed is m square root of m. So if you put that together, okay, the odds go together, so it's 16m square root of, and then the 2m's go together, 2m. So that's our final answer. Okay, that was kind of all over the place. I apologize. All right, now another way you could do this is if you look at 512 and you immediately know, well, still, we're going to separate the 512 times the square root of m cubed. Okay, just looking at the 512, if you know that 512 is, what is it, 256 times 2? Okay, and you know that 256 is the square root, or sorry, the square root of 256 is 16. Well, then this changes to 16. Our square root of 2 just stays there. Okay, well, you can rewrite m cubed as square root of m squared times square root of m. And we know the square root of anything squared is just that. So that's m square root of m. Okay, so combine what's on the outside, 16m. Combine what's on the inside, square root of 2m. You get the same thing. Okay, yes, there's a 1 there. Now the key here is knowing that 256 goes into 512 and that 256 is a perfect square. Okay, that's why I prefer the cake method, is because you don't have to remember that, but many people like it this way, which is fine too. All right, so whichever way you choose, I want you to try this by yourself. This one's actually quite easier. Okay, so first we're going to break square root of 45 p squared into square root of 45 times the square root of p squared. Okay, so I want you to go ahead and pause this video and try to figure out what this is, and then we'll go over it. Okay, hopefully you've tried this one on your own, okay? But if you're completely lost, pay attention. Hopefully you can figure it out. So the square root of anything squared is just that. So the square root of p squared, that's just p. Okay, that's pretty simple. All right, let's look at example 3. Now this is done pretty much the same way as everything else, okay? But we do have this number right here in front. And all this number tells us is we're multiplying this by 7. Okay, so I'm going to rewrite this and kind of chunk it up a little bit. So this is just 7 times square root of 96 times square root of m to the 7th times square root of n to the 10th. Okay, and if we do square root of 96, okay, I'm going to break it down using the cake method. You surely don't have to. This is 248, 224, 212, 26, 23, 31. Okay, so circle our pairs. And we have 2 leftovers, and we have more than 1 leftovers, we multiply them. So we have 2 pairs of 2, so we would multiply those. Those would go up front. So 2 times 2 is 4. Square root of, well, 2 times 3 is just 6. Okay, m to the 7th is 1, 2, 3, 4, 5, 6, 7. You have a pair, and a pair. So if you multiply all your pairs, m times m times m is m cubed. And then you have 1 left over, so you have square root of m. Okay. And then you have your n to the 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Circle your pairs. Circle, 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 circle. None left over, so you don't have any under the square root. You have 1, 2, 3, 4, 5. So n times n times n times n times n is just n to the 5th. And don't forget about this 7 here. Okay, so the hard part's done. Now all we're going to do is put what's on the outside together and what's on the inside together. Okay, so we have a 7 on the outside and a 4. So when you multiply 7 times 4, that's 28. Okay, we have an m cubed on the outside, and we have an n to the 5th on the outside. And then we have a square root of, well, we have a 6 and an m. And this will be your final answer. All right, I want you to try to give example 4 a try on your own. So pause this, do as best as you can. Who cares if you screwed up, you have an eraser, and then we'll go over it when you get back. All right, so let's look at this. If I break this apart, this is the same thing as -3 times square root of 24 times square root of a to the fourth times square root of b squared times square root of c cubed. All right, so let's break it down. Square root of 24, and I'll show you the other way this time. Like I said, you can pick whatever way you're most comfortable with. 24, well, we know the square root of 24 is the same thing as square root of 4 times square root of 6. And the square root of 4 is 2. So this is just 2 square root of 6. Okay, we know that a to the fourth, square root of a to the fourth is just square root of a squared times square root of a squared. Well, square root of anything squared is just itself, so this is just a times a, which is a squared. So we can say this is just a squared. Square root of b squared, well, once again, we have the square root and the square cancel each other out because they're inverses, so this is just b. And then if we have square root of c cubed, that's just square root of c squared times square root of c. And then the square root cancel each other out, so this is just c squared of c. Once again, don't forget this -3 out front. Okay, now if we put it all together, we have -3 times 2 gives me a -6. We have an a squared on the outside. We have a b on the outside, and we have a c on the outside. And then on the inside, we have a 6 and a c, and that should be your final answer.